Right, welcome back for another week of stats. I know that it is Anzac weekend and so technically we do not have a stats class, so whenever you watch this that is fine, but I figured that since I didn't see you over the Easter weekend and would not be seeing you over Anzac weekend, you might benefit from having a little bit more learning to tide you over. I'll keep it really short. This week I just want to make sure that you've remembered what risk and relative risk are from level 2 probability last year. Each and every one of you should have done this last year. I know if you came from my class that you definitely did. Risk really is just probability, so we'll go over just a couple of questions really quickly. Risk is also known as absolute risk. It is just the chance of something happening, the probability. It really just has the negative connotation as with the word risk. Relative risk, however, is not a probability. It's a comparison of two. Because it's not a probability, it can have a value of over 1, whereas a probability, as in risk or absolute risk, must have a probability between, or a value between 0 and 1. So let's look at an example. We might have some kind of vaccine trial question. We might then be looking at a sample of people that have either been vaccinated or have not been vaccinated. As a result of these vaccinations, this person may have a particular disease, or they may not have the disease. Of course, we may also have our totals written in here for us. Now, in level 3, it's quite rare that you would have a fully completed table given to you straight away. Chances are you would need to complete some of this first, but we will launch straight in. Let's say that in this particular problem, we have 39 people that have the disease and were vaccinated, 87 people with the disease but not vaccinated, 561 without the disease were vaccinated, 313 neither. That would give us totals of 600 received the vaccination, 400 did not. The total number of people with the disease would be 126, and the total of not having the disease would be 874. This gives us our overall total of 1,000 people in our survey or sample. All right, I'm sure there would be a much bigger question there. You would be given lots more information to fill this out, but we're just starting from this point. Now, the first kind of risk question that you might get would be quite simple and would just be an absolute risk. This might be something like, let's say that question A is, what is the risk of a random person having the disease? Now, risk being just probability means that this is exactly the same thing as me saying the probability of someone having the disease. They are exactly the same. The risk of a random person having the disease and the probability of someone having the disease. The only reason I'm saying random here is to show that it is out of our total sample size of 1,000. That means that we're looking at every single person with the disease, which is 126. And as I just said, that is out of everyone in this sample, 1,000. Which of course is 0.126. If you were asked to interpret this question, you would be able to say that this would mean the risk of a random person having said disease is 0.126, rather than using the language of probability. Just read the question and make sure you answer it in a similar way. That's the first kind. The second kind of risk question is relative risk. So, let's have a look at one of these. We might be asked something like, how many times as likely would it be, is it, not as if, is it for an unvaccinated sheep, or person, I think this question is actually, an unvaccinated person. I'm looking at too many examples in all my different books. An unvaccinated person to get the disease, and we'll be comparing that to something, as per my note up the top. If we're looking at an unvaccinated person getting the disease, we would then want to compare that to a vaccinated person. So, how many times as likely is it for an unvaccinated person to get the disease compared to a vaccinated person? The key language you're looking for is times as likely. As soon as you see something like this, 2 times as likely, half as likely, how many times as likely, you are immediately looking at relative risk. This is when you are comparing to individual risks. So we need to pull out some specifics from the question. First of all, we need to find the probability that an unvaccinated person has got the disease. So we've limited our sample space not to our 1,000, but just to look at the unvaccinated. So, as a probability, we would be looking at the chance of us getting the disease, given that we are just looking at these not vaccinated people, writing it as a conditional probability, just like last week. Now, of course, conditional probability, we're limiting our sample space, which would mean our probability, or our absolute risk in this case, is 87 out of 400. Disease, from our disease column that I pointed out before, out of our limited total, not of 1,000, but our non-vaccinated, unvaccinated people. If you have a calculator, you would be able to see that this does equal 0.2175. That is an absolute risk, a simple probability of this information here. Second part of this question. We're not actually calculating how many times as likely it is yet. We need to find the probabilities first. So the second part of this question is to do a very similar thing, but with our vaccinated person, which means we're not looking at the complement of vaccinated anymore. We are looking at the vaccination. So once again, we're limiting our sample space, but we are still looking at those that have the disease. So again, the disease column, we're looking at just our 39 out of this time our 600. Once again, if you have a calculator, follow through with me. That equals 0.065. As I said before, both of these are simply probabilities or absolute risks. So we haven't finished the question yet. All we need to do is compare these two. We've got both parts of this question ready to go. Next we need to look at the order. we spoke about the unvaccinated person first. So that's what I start with. And I'm going to compare it to a second thing, a vaccinated person. To find out how many times is likely, we need to get that ratio. So all I do is 0.2175 divided by my second, which is 0.065. If I complete that division, I would get an answer of 3.35. I've rounded that to 2 decimal places. It went on a lot further than that. And that is my relative risk, also known as a likelihood ratio. If I'm to interpret this question, I can now say, in answer to this question, that an unvaccinated person is approximately 3.35 times as likely to get the disease compared to a vaccinated person. Note that I am talking about the order there. This makes sense because we know that vaccines are good for us, they help prevent diseases, and so we are expecting that this number is going to be greater than 1 because we expect that an unvaccinated person is more likely to get a disease, a number greater than 1. If by mistake you switched these numbers around and you actually did 0.065 divided by 0.2175, you would get a number that is much smaller than 1. Make sure that you always check that, make sure the question and your answer make sense together in case you've made that silly mistake. Final point to note in this video, what that might look like in a probability tree. If we enter in just some of the same information into a probability tree, starting with vaccinated and non-vaccinated, and then our second stem being diseased or not diseased, same for both. We might have been given the information from the beginning. Whoops, I would need another 0 there. That the probability of being a diseased person, given that you were vaccinated, was the very small probability of 0.065. Now, in another sort of question, you may not have been given the second probability down here, what we worked with in part B of this question when we began. You may not have been given your 0.2175. So in a different type of question, you may actually have been told something like, the probability of having the disease if you are not vaccinated is 3 times as likely. So someone is making a claim that they know something to be true or that they believe something to be true. Now, for the purposes of this example, I'll just use 3 times as likely, but we know we calculated something slightly different. Often you'll see a question that's suggesting that, say, a pharmaceutical company has made the claim that something is 3 times as likely or will reduce the risk of something by a certain amount. You're still looking at relative risk. If you were given a question like this, where you only have one of the conditional probabilities, but you were given a claim or a piece of information like this, it simply means that you would need to do your 0.065 multiplied by 3, or whatever this number was. In the actual example, it was 3.35. That will get you your missing conditional probability, and you're done. You can continue the question from there. There was a question like this from the Walker Maths book in the previous week's set of work, where you're looking at something being twice as likely. Same kind of problem. Make sure you use every piece of information from the question, no matter how it's worded. I will attach a couple of pages for you to work on if you need to, but remember that this is recap. This should have been comfortable for you. You have done it in level 2. But they do like to throw in one question on risk and relative risk in a level 3 problem. Have fun.